Yo, 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 looking at 8.2. We're actually going to be doing this twice. We'll be doing this Thursday and Friday as well as Monday and Tuesday, just because it's a lot of material. Um, and a lot of what you do in here is for the rest of the semester. And definitely lays the groundwork to all of trigonometry as well as in everything that you're going to be doing in calculus. So like we did last time, going in between degrees and radians, so we have 360 is equal to 2 pi here. And this is just asking us for how much is pi over 6 or 30 degrees over 360. So if you are any time that you're looking at pi over 6 and this confuses you, you can always convert it to degrees and deal with that. So if you convert this to degrees, you get 30 degrees, and then you're dealing with 360, you still end up with 1/12. So you're always in control of what you're dealing with unless you're forced to by it asking you. And so in this next section here, all of these identities here, so cosine is x over r, and r is just our radius of the unit circle, and that value is 1, unless we change, of course, the circle, but the standard radius value is 1. So a lot of times you just might see x dealing with cosine because r is 1 and it reduces to just x. And so a lot of times you might just see that. And so now we're just going to be dealing with these. So get used to all of these. I've kind of color-coded them. And hopefully by the end of this, you'll be able to do it on your own. So I've kind of left some crumbs here. So we're given these values of what our cosine and our sine are at a particular location on the unit circle. And we're simply just using those values to create other values using different trigonometric functions. So we have sine, cosine, and tangent. And these are just dealing with these ratios around the unit circle. And so we have y over r, so we're just replacing it. So my y value is negative 24, and my r value is positive 25. So the negative will always go with the y value, and the bottom value of radius, because it's dealing with distance, will always be positive. And then we're just using these values. So here we already have these values, so our sine or cosine we have here is dealing with our tangent. So we just take those values and divide them. So our 25's cancel, leaving us with the negative 24 over 7. So everything we're going to be doing today is dealing with these ratios. Same thing going on here. We're just looking at the given values. We don't have to calculate anything until we get to here. There's 25's cancel, and so do the negatives. Here we're making our way around the unit circle. So I will be providing a unit circle for you, and all you have to do is search for it on the internet. It will become your best friend, and we're just trying to find this location. So remember, when we are given a radian or a degree, that negative doesn't mean it's less than 0. It means we went in the negative direction. So in negative direction, we're going clockwise. All right, so I've went 2 pi, but if you're like, hey, I don't like that, I want to change it to 360, that's fine too. So it just means I've started here and I'm going around in this direction, 2 pi or 360, and this is the location that I'm talking about. So I'm dealing with this point 1, 0, where my x value is 1 or my cosine is 1, and my y value is 0 or my sine value is 0. And we can also say, hey, well, I thought you said this was x over r. R is 1 here. Same thing here. We're going by pi over 2 or 90 degrees. So we're starting here. And since it's positive, we're moving in this direction. So this is the point we're talking about, 0, 1. So my x value or my cosine is 0, and my y or my sine is 1. Oh, and then looking at cosecant, same thing with what we're dealing with up here. We're just looking at, this is cosecant here, which is r over y. So it's just the reciprocal of our sine. And the same thing with our secant, which is just the reciprocal of our cosine. And so when we're dealing with this, and we have y's on the bottom, we can see our y value is indeed 0. So we can't divide by 0, so that's why they're undefined. Same thing here. They're undefined here because our x's are 0, and we're divided by 0, which we cannot do. Then we have negative pi over 2. Once again, we're going in a clockwise direction. We're in negative direction by 90 degrees or pi over 2. So we're looking at 0, negative 1 and following through. And then 5 pi. So now we have something that's it's more than one rotation. All right. So, and if you want to, you can turn that into degrees if you want to. It's positive, so we're going in this direction. So we can either count by pi's or 180s. So 1, 2, 3, 4, and 5. And this is the point we're dealing with in all of these answers. and then negative 6 pi, so we're traveling in this negative direction, so 2 pi, or negative 2 pi, negative 4 pi, negative 6 pi, so we're dealing with that location. So we're dealing with my x value of 1, y value of 0, and then we just follow with those same ratios. So we know what our, so we're just simply replacing my y value of 0, our radius is 1, 0 divided by 1 is 0, and so forth. So we're looking at negative 3 pi over 2, so we're going in a negative direction, and this is negative 270 degrees, or we're traveling 3 pi over 2's, or 3 90 degrees. So that is 1 90 degree in the negative direction, 2 90 degrees, 3 90 degrees for a total of 270, or negative 3 pi over 2. So I'm dealing with my x is 0, my y is 1, and my radius is 1. And so we just deal with those same ratios again. So once you know your x, your y, and your r values, you just simply plug them in and simplify. Same exact problem here, so that might happen sometimes. So traveling in a negative direction by 390 degrees, or 3 pi over 2's. And we just replace those values with our what we have with our x and y. Here we're wondering what quadrant we're in. So I don't care what this value is. I care if it's positive or negative. So my y value is positive. My x value is negative. Negative, positive. That only happens in quadrant 2. Here we'll be using our calculator. So you need to, on your calculator, make sure that it is in radians. How do we know it's in radians? Because there is no degree sign on this number. So you just simply push mode on your calculator. And then on the third row down, you'll see radian and degree. You just need to make sure that radian is highlighted. You hit enter, and then you can hit second in mode to quit and go back to the home screen. And then you just hit sign, you plug in that number, and just make sure you round properly. Here, make sure that you do each of these separately because you are rounding. Even though sine and cosecant are reciprocals of each other, we should, in theory, just say 1 divided by negative 4, 0.49, and I should get this value. But the problem is this is rounded. So in order to get this value here, just do 1 divided by sine of negative 2.63, and that's how I get this value. If you don't round these values, then you could do that, but it's just easier, and sometimes it might work for you because of the way that it rounds, and sometimes it won't. So I'd rather you practice doing it what gets it right every time. So we use cosine here. Its inverse is secant, so this would be 1 divided by cosine of negative 2.16. That's how I got this value. Tangent, you just plug that in, and then to get cotangent, 1 divided by tangent of negative 2.63 is how I get this value. And we repeat this process for the one here as well. So very similar things. It seems like we're happening all the time. It's just to kind of get you used to it. And then finding the quadrant, once again, I'm only concerned about these positive and negative. So I am, my y value is negative, my x value is negative. That only happens in quadrant 3. And then same thing here, my y value is positive, my x value is negative. That only happens in quadrant 2. Here we are, we're traveling 7 pi over 6. This is in the positive direction, so I simply go around. I stop at pi over 6. It's asking for sine. That is my y value, and we're done. Looking for 3 pi over 2, so I simply travel in the positive direction. Here we are. Cosine of that, so that is my x value, and there we are. Here we're looking for secant of pi, so I travel around to pi. That means I am dealing with negative 1, 0. I'm dealing with secant, which is the inverse of cosine, so that is r over x, so radius is 1. My x value is negative 1. 1 divided by negative 1 is negative 1. Cotangent, so we're going to 4 pi over 3, and we'll just use this one over here. So 4 pi over 3 is here, so we're using these values. So x over y, so that's negative 1/2 over negative root 3 over 2, and we just simplify. So there we go. Here, negative 5 pi over 6, so we're traveling in the negative direction. And so you're like, well, that's 7 pi over 6, but that's in the positive direction. So it will be helpful if you just you can even create your own unit circle with negative values. Asking for cosine, so that is the x value, and that's all we do. Tangent of 13 pi over 4. So we're traveling by 13 pi over 4s, or 13 45 degrees, and this is in a positive direction. So I travel 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So that's one way of doing it. I'm sure as you do this more and more, you'll find a more efficient way. Since we're first introduced to it, this is kind of what's happening. So here we can use this equation given here, or we can use the x squared plus y squared equals r squared. I find this a little bit easier. It helps us get rid of fractions. So here we need the x, y, and r value. So we just simply look at what's given. It is our cosine, so that's x over r. So I know my x value is 3. I know my r value is 5. I know I'm looking for my y value. Once you get to here, this answer can be positive or negative, so we need to look back at what we're given here. So it tells us our y value is greater than 0 or positive. That's how I know that this is positive 4 instead of negative 4. And then we have all of our ratios from earlier. We know our x, our y, and our r values, so we just simply plug those in and simplify if necessary. Same thing happening here, and here's the case where we come down here. It's really easy to go, oh, I got 5, and you go in and you're going to get 1, 2, 3, 4, 5 of them incorrect because it's negative 5 because it tells us x is less than 0. So watch out for that. But once you get that negative value in it, you're just simply plugging in your x, y, and r values and simplifying if necessary. Same thing happening here. This one, we do end up with a square root, so we do need to simplify this. We can't leave it as root 63. That can be reduced to 3 root 7. Also, we're told that y is less than 0, so we know that this is negative. We simply plug that in, and we simplify when necessary. Same thing happening here, except we don't have to figure out. We know everything was given to us. This is our y over r, so we know r is 17, y is 15. This is x over r, so I know my x is 8. I simply plug it in and simplify if necessary. Here we're finding out where this is on the coordinate plane, what quadrant. And so I look at here, this is my y value, it's positive. So I just put positive there. This is my x value, and it's negative. This happens in quadrant 2. Here, I'm looking here. Our r is 1, so I'm just looking that they're both positive. Where does this happen? Quadrant 1. And once again, they're both positive. This happens in quadrant 1.